Once we have established good quality plasmid preparations from DNA analysis using the nanodrop, we can now perform a restriction enzyme digest and gel electrophoresis of our plasmid preparations to confirm the conformation of the plasmid and the size of the digested product. Prepare the reaction as follows. Remember to keep the restriction enzyme stock on ice when it is not being used, and always use a clean or new tip when removing the enzyme from the enzyme stock. Gently mix the sample and incubate the reaction in a 37-degree incubator for 1 to 4 hours. Next, a gel electrophoresis will be run to confirm the conformation of the plasmid and the size of its digested product. In our experiment, the positive PGD2.1 AMI-E candidates contain a single site for the BAMH1 and XHO1. Therefore, after restriction digestion, the positive candidates should obtain 2 fragments with expected sizes of approximately 3.8 kb and 2 kb, corresponding to the PGD2.1 vector and the inserted amylase gene. You can create a simulated agarose gel to see the size of the bands we would expect to see using SnapGene. The double restriction cut plasmid DNA is separated by gel electrophoresis on a 1% agarose gel, and we will encounter DNA molecules with conformations other than the linear form, such as covalently closed, circular, or open circular. For example, a covalently closed circular DNA molecule, being more compact, will move through the gel at a different rate, faster compared with its linear counterpart. In the cell, plasmid DNA molecules primarily exist in a supercoiled double-strand, covalently closed circular form. Upon extraction from the cell, a proportion of the plasmid molecules become nicked on either one or both strands. As a result, some of the plasmid circles become linear molecules, others are no longer supercoiled. Although all of these molecules contain the same number of nucleotides and therefore have the same molecular weight, they migrate at different rates through agarose gels. As expected, most plasmid DNA preparations will contain a mixture of all 3 forms, the covalently closed circular form normally being the most abundant. Learning objective: understand the function of restriction enzymes. From a given plasmid map, determine restriction enzyme sites and fragment sizes. Be able to compare the DNA standards with the digested bands to determine DNA size.